Okay, now let's talk about what happens when we multiply our parent function by a number greater than 1. So like 2, 3, 4, something like that. All right, notice that we have our parent function here, y equals x. All right, but then we have this green line. All right, notice that it's a little more steep than our parent function. And that's because the equation here is 2 times our parent function, x. And that just means it's 2x. All right. So whenever we have a number greater than 1, it is more steep. All right. So we say it is more steep by 2. So when we have these examples here and we're trying to describe what's happening, for instance, for number 1, 3 times f of x is more steep by 3. And this equation is just 3x. All right, and we say more steep by 3. So in number 2, it's more steep by 5. Number 3, it's more steep by 4. And you can complete number 6. So in the next section, when we have our a in between 0 and 1, meaning a fraction, notice that we have our parent function here in black. But if we look at our purple graph, it's less steep. So for instance, this example is a half of our parent function. All right, or we say 1/2 times our f of x. All right, so that means this is less steep by a half. All right, less steep by half. So then that's the same thing with number 5. It's less steep by a third. Right, so it means it gets closer and closer to our x-axis as we continue to go up, or down rather, in numbers. All right, so that's number 5 is less steep by a third. Number 6 is less steep by 1/5, right? And number 7 is less steep. Well, this is also called compression. So if you start hearing compression, less steep, it means the same thing. And I'm going to have you to do number 8. All right, when we have the negative of our function, then there's a reflection going on here. Notice our parent function in black. All right, and the different function is in red. Here, this represents a reflection across the x-axis. All right, it represents a reflection across the x-axis. So this is basically negative f of x, which is negative x. And yes, it's a reflection across the x-axis. So there's a little combination going on here with number 9. There's a reflection across our x-axis, but also we added one on the outside of our f of x, which means we're going up 1. So we're kind of putting in a little review from the previous video. All right. Main thing is to recognize this is a reflection across the x-axis. That's the main thing. All right, number 10, it's a reflection across the x-axis. All right, remember in number 9, we're going up 1. In number 10, we're going down 4. Where does that come from? The -4 right here and the +1 here. All right, so we had a combination of things happening here. All right, and number 11, that negative 3 times f of x, that negative part says it's reflecting across the x-axis, right? And that's what we write here. And then that 3 says, remember, we're going to come back up here for review, right? It's more steep. So, reflection across the x-axis and more steep, or we also call it a vertical stretch, by 3. My apologies. All right, and you complete 12. Now, if we have f of negative x, where that negative is inside the parentheses, this represents a reflection across the y-axis. All right, this represents a reflection across the y-axis. So when we have 2 times f of negative x, first off, it's a reflection across the y-axis because of the negative x inside parentheses. And the 2 is representing a vertical stretch, or it's more steep by 2. All right, number 14, we have 1/2 times f of negative x. That f of negative x says that it reflects across the y-axis. And that 1/2 out front says that there's a compression, or it's less steep by half. I want you to try 15 and 16, and we'll talk about it in class.